So hello and welcome back. So this video is for class 12th and we will continue with electromagnetic induction. So in the previous class we discussed the concept of self-inductance and mutual inductance. Okay, now these concepts are very important. Even though if you found them tedious, make sure that you go through them properly, right, and understand the formulae very well. Okay, you could have any numerical based on it or even any theory question that can be asked on these topics. Today we are going to find a relationship between EMF and inductance, and we are going to study about the AC generator. Okay, so let's begin. So first let us see a relationship between EMF and inductance. First let us see it for the self-inductance. So we know that the flux linkage of a coil will be given by N phi is equal to Li. Okay, let us call this equation number 1. And by Faraday's law, we know that EMF generated E is equal to minus d N phi by dt. Okay, this N phi stands for the flux linkage. Okay, if we are having a coil of N number of turns. So comparing this with equation 1, you can see N phi is equal to Li. So this equation will become E is equal to minus d by dt, and in the bracket now we will put as Li. Now L is a constant, that is the inductance, so L can come out of the bracket. So therefore we will get E is equal to minus L di by dt. Okay, so this is the relation. So this gives that the EMF is generated due to the rate of change of electric current, right? This can give a relationship between inductance, EMF and current. The same treatment we can do for the mutual inductance as well. That is, we can write N phi is equal to the mutual inductance into the current. Okay, again we get E is equal to minus d N phi by dt. N phi is equal to Mi, so we get E is equal to minus M di by dt. Okay, so the relationship will be the same, only here instead of self we are having the mutual inductance. Okay, so I hope that was understood. Now once again let us talk about this phenomena of inductance. See, what happens is when we saw the self-inductance, we were having a coil, right, and from that coil we were passing an AC current. As an AC current was going through the coil, it was having some self-inductance which was opposing the EMF that was created. The inductance, it was creating its own electric field, its own EMF, correct? So basically what this inductance does, it tries to oppose the EMF that we are providing to it, right? That means this is the EMF actually that we have set up, the AC EMF, correct? It is trying to pass some current I through the coil. But what is inductance doing? It is trying to stop that current. That is why we also call that induced EMF, we call as the back EMF, correct? So it is almost like the property of inertia in mechanics, right? We have studied inertia in 9th class and in 11th class. What happens? Every body has a tendency to be at rest or in motion, okay, unless an external force is applied. Similarly, any kind of conductor, it will have this property of inductance, where it will try to oppose any change in the EMF, correct? And that opposition is what gives rise to electromagnetic induction, correct? So, and what happens now? So this battery that we have supplied, this will have to do more work, correct? It will have to do work to pass that electric current because it is facing an opposition from the back EMF. And because of this work done, there is some potential energy that gets stored in our inductor. Okay, inductor means this coil. Okay, so now let us find the relationship for that work done. Okay, so this is again a very easy derivation. So in this given case, we can write the power dissipated P is equal to dW by dt. Okay, that is something we already know. Power is the rate at which work is done, and which is equal to E multiplied by I. Okay, we will not take the sign. EI from where we are getting? I hope from 11th class. Power is equal to potential difference into current. P is equal to VI. So here instead of potential difference we are taking the EMF. So what you get? P is equal to dW by dt, which is equal to E into I. Right. So this is the power that is dissipated. Now, how much is E? E is minus L di by dt. So we can write this as dW by dt equal to minus L di by dt into I. dt we can cancel on both sides, so you will get dw is equal to minus L di into I. Now to find total work done, we have to take the integral, right? So we will get total work done W is equal to integral of dw, which is equal to minus L integral of I di, where I goes from 0 to capital I. And how much is integral of I di? Integral of I di is nothing but I square by 2. So you will get therefore work done is equal to minus L I square by 2. So this external power supply that we attached, it will have to do a work of minus L I square by 2 to pass the current. Okay, so that is what we understand from this derivation. Okay, next now we will talk about the AC generator. Now one of the best uses of electromagnetic induction is in the creation of electrical power supply, that is in the generators. So we have DC generators and AC generators. DC generators will create direct current, AC generators will create an alternating current. And I'm sure you remember this from 10th class, we had discussed this. Okay, so the current that we are getting in our households, that is the AC current. Okay, reason that we are using AC current is it is very easy to transport AC current over large distances. The current that we are using in our mobile phones, that is a DC current, or in our watches, okay, the small cells that we have, that is the DC current. Now we will talk about the AC generator. So here is the diagram from the textbook. Okay, now what does the AC generator consist of? It will have, first of all, it will need a magnetic field. Okay, then there will be a coil inside. Okay, now this coil is extremely important. What we are going to do, we will rotate the coil in that magnetic field. By rotating the coil, there is change in the magnetic flux for that coil. And of course, you know now, as the magnetic flux will change, there will be EMF set up, and that EMF is nothing but the current that we are going to use. Okay, so I hope that given diagram is understood. I will also show you a simplified diagram on the board. So what is an AC generator? It is a device that will convert mechanical energy into electrical energy. Now what is the mechanical energy? Basically you want that coil to start turning, correct? And how can we turn it? Either we can turn it by hand, but of course that will take so much of energy, human beings cannot give it. So we make the use of either thermal energy, that is we take coal. Okay, by coal we are able to heat water, which converts into steam, and it is that steam that actually runs the turbines. Okay, turbines means big fans are there. Okay, that turbine is attached to the coil that you are seeing. So steam will rotate the turbine will rotate the coil, and as coil will rotate, it is going to create an EMF, that is the electric current. Or we can use water, that is a hydroelectric power plant. What we'll do, we'll drop water from a large height, that water will move the turbine, again turbine moves the coil creates electrical energy. Okay, or we can use wind energy, or the best in the sense, the most efficient, that is the nuclear energy. Okay, so these are different ways in which we can use the mechanical energy. But any type of energy we are using, the fundamental principle remains the same. Okay, now let us see it on the board. So what we have, first we will need a strong magnetic field. Okay, then this is the coil A, B, C, D. It is a rectangular coil. Now this coil is attached to two slip rings. Okay, and these slip rings are then attached to the output. Okay, where we are going to get our final current. Again, in 10th standard we had completely discussed this. Okay, so I hope you remember that, and that same knowledge you will be able to use here as well. So here is where we have our coil. Imagine my hand is the coil. Initially we'll keep the coil as if, let us assume that the area vector and magnetic field are parallel. Okay, now how do you find the area vector? If this is the plane of the coil, area vector will be perpendicular. So if the coil is like this, the area vector and magnetic field, the magnetic field is going from north to south, right? So when the coil is like this, okay, then area vector is perpendicular to the magnetic field. So this is our initial position, imagine. Then what we do, we give some kind of mechanical energy that is going to rotate the coil now. And of course, as the coil will rotate, the effective area will change, there will be flux, and that flux will create an EMF, which is what we are going to get from an output. Because we are having a slip rings in place, the current you will get from this will be alternating. So we will get an AC current from this. For a DC current, instead of these slip rings, we will use something called as a split ring. Okay, but again that is not included in our syllabus, so I will not spend any time on it. So anyway, so mechanical energy we are giving, that is rotating the coil. As the coil will rotate, it will produce the EMF. Now let us see some formulae for the same. So what is going to happen? The coil will start to rotate. So by the Faraday's law, we can get EMF is equal to minus N d phi by dt. Okay. How much is phi? Phi is going to be B dot A. Okay. So this will be equal to minus N d by dt, and phi we will write as B A cos of theta. B dot A is nothing but BA cos theta. Let us assume that it is moving with an angular frequency omega, then theta will be omega into T. So you will get, therefore, E is equal to minus N d by dt, okay, BA cos of omega T. Okay, that is the relation. Now B and A are again constants, so you will get this as minus N BA d cos omega t by dt. Okay, this is the E. Now we know that derivative of cos theta is minus sin theta, so we will get this as NBA sin omega t. This relation gives the EMF. What will be the maximum value of the EMF? That will be when sin omega t is 1. Okay, so the maximum value of that EMF, E max, will be equal to NBA. Minimum value we will get when sin omega t is minus 1. So minimum value will be minus NBA. When it will be 0, it will be 0 when sin omega t is also, when omega t is 90 degrees. So sin omega t, when omega t is 0, so we will get sin of 0 as 0. Okay, so this gives the EMF. So when our coil is rotating, it keeps on generating an EMF that is given by this relation. Okay, now what you see, the maximum value will be NBA. So it is basically representing a sine wave, correct? So that is why when we get the AC current, okay, it is in a sinusoidal wave. Okay, we can represent it by a sine function, correct? So that is how an AC generator works. Now we can of course control at what frequency it is going to turn. Okay, so depending upon the number of frequency, the power output can be changed, because you can see that omega t is nothing but 2 pi nu. Okay, so again depending upon the frequency, the output can be changed by it. In India, we are having a frequency of 50 Hertz. In countries like US, the frequency is 60 Hertz. So different countries, they have decided upon a limit for that AC frequency that they want to use.